Welcome, everyone. This is going to be Onboard Comprehensive Autodesk Tools for CAM and Nesting. If you have any questions, please type those into the Questions tab on the sidebar, and we will address those at the end of the presentation. Now, to get started, I'm going to start with a brief overview of M2 Technologies. M2 is a consulting firm focused on productivity, improving manufacturing process efficiency, and reducing manufacturing costs. Using general design and best-in-class manufacturing and asset management processes, our team of industry experts can help you become more sustainable, more profitable, and more prepared to meet the demands of urbanization in a rapidly changing world. We are committed to helping clients realize the business benefits of BIM and asset management quickly and economically by facilitating the use of innovative processes and technologies. Whether it's streamlining your product design, maximizing asset longevity, or optimizing your processes, our team is one of the most experienced groups of manufacturing technology consulting professionals. We partner with world leaders such as Autodesk, Panzura, EaglePoint, and Bluebeam to utilize innovative technologies and methodologies to empower sustainable manufacturing and overcome local challenges. To support the industry, we offer a wide range of services, including CAD management, simulation, data management, CAM, CIO advisories, and training. My name is Tristian Gunderson. I'm an applications engineer here at M2 Technologies. I work with our clients to help them optimize their workflows, get the most out of their software, and utilize cutting-edge technology. So as we begin today, we're going to be covering CAM and nesting. We'll start with an overview, then look at the different products and bundles available through Autodesk. And lastly, we'll do an in-depth analysis of the different products available. So to begin with, we're going to go over some of the common terminology we'll be using throughout this webinar. I'll start with nesting. Nesting is a tool for placing multiple copies of components or several different components within a single two-dimensional sheet. This is typically used for preparing for any kind of two-axis cutting operation. Two-axis cutting is performed with either milling machines, or often is done instead with water jets, plasma, or laser cutters, as these allow for better precision and smaller cutting tool. Next, we have our 2.5 axis milling. 2.5 axis milling is a type of 3-axis milling, but rather than having fluid transitions between the 3 axes, 2.5 axis only works in 2 directions at once, so often works by working down through material in layers. Next is the 3-axis milling, which allows for fluid motion through all 3 directions. So working on a flat workpiece like the 2D cutting or 2.5 axis milling, but able to create complex arcs and curves and slopes with the milling operations. Next, we have 3+2 axis milling, also often referred to as 5-axis indexing, which allows for 3-axis milling as well as 3-axis rotation of the workpiece in order to have milling operations at different angles. However, you are not able to rotate the workpiece while performing milling operations, which leads to the 5-axis milling, which allows for fluid motion in all 5 axes in order to perform unique geometry constraints and have the most flexible cutting options. Next, we have turning, which typically works on a standard CNC lathe, in which you have a cutting tool, which can move in 2 axes of motion which interacts with a rotating stock in order to create revolved surfaces. Next is mill turning, which allows to have a rotating cutting piece along with the standard turning operations, which is typically used for creating drill holes that align on the outside rather than through the center of the workpiece. From mill turning, the next step up is the 4-axis milling, which has the turning operations as well as the mill turn rotating cutting tool. But within 4-axis milling, the cutting tool has more capabilities similar to 3-axis milling, using indexing along that 4th axis with the lathe. Then lastly, we can get into electric discharge machining, which uses electrodes to create very precise and small details. And lastly, additive manufacturing, which instead of removing materials from a workpiece, adds material together, usually either by melting material and then applying it with an applicator in layers, or using lasers to connect powder together into a single shape. So looking at the collections available from Autodesk, we'll start with the PDM, or Product Design and Manufacturing collection. The Product Design and Manufacturing collection includes a number of different applications and tools, but we're going to be focusing on Fusion 360, which has both CAM and nesting capabilities. Then Inventor CAM, which is CAM features built in for Inventor, and Inventor Nesting, which likewise is the nesting, which both of these interact directly with Inventor. And lastly in the collection is HSM Works, which works as a CAM tool for outside CAD programs, specifically SolidWorks. Next, we have a few additional applications which can be used for more specific applications or a little more power within your CAM toolset. First is Feature CAM, which provides a wizard-based feature recognition. Then there's Power Mill, Power Shape, and Power Inspect, all which provide different aspects from milling, nesting, to probing. And lastly, CAMplete, to help analyze and optimize your post-processing. So we're going to start by looking at Fusion 360. Fusion 360 is a comprehensive CAD, CAM, and CAE, which is computer-aided engineering software. Within its CAM and nesting capabilities, Fusion 360 has 2.5 up to 5-axis milling, turning, and 4-axis milling, as well as cutting operations, including water jet, laser cutting, and plasma cutting. With the extension, it also has the ability to do nesting, which can then be directly used within its cutting operations, such as the water jet, laser, and plasma, or be exported for other software. And lastly, it has probing capabilities to program the probing along with your milling operations. Some additional tools that Fusion 360 includes along these lines is tools for programming additive manufacturing, as well as a PCB design and printing tool. And lastly, built-in simulation. You can test your components in the same workspace that you design their manufacturing processes. So while Fusion 360's base version has a lot of these tools, there are extensions that help you best meet your exact needs. The machining extension provides additional tools for 3-axis, 5-axis milling, as well as toolpath editing and optimization. Next, there's the nesting and fabrication extension, which gives you all the tools you need for creating your nested sheets for your cutting operations. And lastly is the additive build extension, which gives tools to help with 3D metal printing. One of the keys to Fusion is the seamless transition between design, simulation, and manufacturing workspaces, which allows for quick design changes and automatic updates through your different spaces. The highlights of this product are the all-in-one application, as we've talked, being able to seamlessly transition between the different workspaces and have any design changes be updated among all of them. Also, Fusion Teams, which is the cloud-based data management site that is connected with Fusion 360. This allows all members of your team to quickly and easily access the latest versions of all models. And lastly is the low entry cost. Fusion 360 comes in at a very low entry cost compared to most CAD applications, especially considering all of the additional CAM and nesting tools built into it. And on top of that, there are often promos running for additional savings. Next, we're going to look at Inventor CAM and Nesting. Both Inventor CAM and Nesting are integrated tools that connect directly with Inventor, so you don't need to change between different applications when you are going from your design to your CAM or nesting. It also utilizes any CAD capabilities, so even if you have either CAD neutral or CAD files from other software, you're able to bring those into Inventor and apply your CAM and nesting operations directly on those files. Within Inventor CAM, you have 2.5 to 5-axis milling, as well as turning and 4-axis milling operations. And lastly, it has specialized adaptive clearing and finishing paths to help quickly optimize your tool paths to get your parts created faster and with the highest precision possible. Inventor nesting allows for automated multi-sheet nesting, so it will calculate best orientation of parts and how to fit those together in order to make the most use out of your material. But it also allows for manual placement and orientation if there is grain direction necessities for different parts, or you need a part to be closer towards the edge or closer towards the center. It allows for all of these manual decisions to be made and will automate the rest of the sheet around it. Lastly, it allows you to create a tool path directly in Inventor CAM, or you can export a DXF file in order to create those cutting tool paths in another program. So again, Inventor CAM and Inventor Nesting are both included in the Product Design and Manufacturing collection, along with Inventor and Fusion 360 and many other softwares, which also includes Inventor Nastran, which can be used for your simulation needs within the same design space. So one of the keys with this is for most Inventor users, they already have a license using the Product Design Manufacturing collection and often don't realize that that comes along with CAM and nesting full integration with their product. This allows for you to work seamlessly within that one design space. And again, working within a design space, you're going to have automated updates within Inventor. So if you make design changes, you can quickly recalculate those tool paths without having to reprogram them. and you're also able to easily save and manage your data using Autodesk Vault. And lastly, in the collection, we have HSM Works. So HSM Works allows for direct integration with SolidWorks. It works as a built-in add-in for SolidWorks. So similarly to with Fusion 360 or Inventor CAM, you are actually able to work directly in that application and not need to switch between different programs in order to do your design work and your CAD program or CAM programming. It also has any CAD connectivity beyond this. So if you're working in a system outside of SolidWorks, you still are able to import any kind of CAD data into HSM Works. And within HSM Works, you're going to have 2.5 to 5-axis milling, as well as turning and mill turn capabilities. Some of the highlights here are the CAD being CAD neutral CAM option, as well as its availability with most subscriptions and its connectivity with SolidWorks. So it's available in the Product Design and Manufacturing collection, but it's also available with any Fusion 360 subscription or Fusion 360 bundle. So lastly, just saying, the ability to work directly in SolidWorks without that, using that direct integration plugin means that you don't need to convert files or switch between applications. You're able to work directly within that one design space. And again, all of those changes are instantly updated for your CAM. So now we're going to get into some of the more specialized CAM programs that Autodesk offers. The first one of which is going to be Feature CAM. So Feature CAM is a heavily wizard-based programming system, which means that you're able to walk step by step through your different features as you create the toolpaths for them. It has intelligent tool and property selection, so it is able to make suggestions about different tool use and the different properties you want for the different operations. Within its CAD capabilities, it has 2.5 to 5-axis milling, turning, and 4-axis milling, as well as bar-fed mills. So any kind of continuous turning process, you are able to program to have that bar feed through, as well as Swiss-type lathes, which the Swiss-type lathes allow for the stock to move as well. And lastly, probing. It also includes automatic feature recognition, as well as interactive feature recognition to either have the system recognize those features and best assign the operations, or be able to do it manually in order to be more specific about what operation you want. And lastly, it has the ability to not only include the clamps and fixtures, but it has systems for avoidance. So not only does it detect any collisions, but it also can help alter the machine path, the tool path, in order to avoid collisions. So Feature CAM is available in the Fusion 360 with Feature CAM. This is the only purchase option for Feature CAM at the moment, but it comes in a standard or an ultimate version. The differences in those two versions are solely with Feature CAM, and both packages include Fusion 360 with the machining extension and HSM Works. So the automatic feature recognition, along with the wizard-based feature tools, allow for quick and easy toolpath creation using Feature CAM. A few of the highlights here are being able to create toolpaths from features, but you also have the ability to use the wizard to create new features by designating feature type and creating those toolpaths. Those features can then be brought back into Fusion 360 or Inventor using the direct import and export tools for those two applications. Now we have a quick video just to kind of highlight the feature recognition within FeatureCAM.
Automation tools with Autodesk FeatureCAM include feature recognition to help you quickly identify and create machinable features from your solid model, such as holes, bosses, and pockets. Simply import your model and navigate through the import wizard to set up your part and define your stock before recognizing features. Feature recognition can be performed in two ways, automatic or interactive. Automatic feature recognition scans your model and generates a list of identified features, which you can choose to machine your part. The automation in FeatureCAM simultaneously creates operations within the feature, containing all the information you need to begin machining, reducing repetitive tasks. If your part requires multiple work offsets, you can use automatic feature recognition to recognize features in different orientations from a combination of setups. Automatic feature recognition provides the quickest result to get you from design to NC code. If you need more control, use interactive feature recognition to program parts by specific feature type. Select faces from your solid model to quickly identify the location and dimensions of your feature. If you're working with an Autodesk Inventor model, you can automatically recognize non-geometric information, such as threads for tapped holes, to further reduce programming time. For any part revisions, import your revised part and quickly make a comparison of features from the new part to the original part using the re-recognition wizard. Your features list is then updated to reflect any changes in the design of your new model. Feature recognition can be used with a range of CNC machine types, giving you the tools you need to simplify and reduce your programming time.
And here we can see some of the feature differences between the standard and the ultimate package. So as you can see, the standard package allows for 2.5 axis and limited 3-axis milling tools, as well as turning and 4-axis wire. Whereas the ultimate gives you all the additional tools, including turn mill, probing, twist type lathes, and 5-axis milling. Also within the ultimate version, you can complete solid modeling within the FeatureCAM tool, as well as using machine simulation, machine limits, and verification export. Next, we're going to move on to Power Mill. So Power Mill is another CAM application available along with Fusion 360. Power Mill has 2.5 to 5-axis milling capabilities, as well as turning and 4-axis milling. It also has probing capabilities. On top of this, it has additive manufacturing programming, as well as specific tools for blisk and impeller machining in order to get those complex 5-axis milling shapes. It also is able to program the machining of electrodes, which can be designed using a combination of Power Mill and Power Shape. And it has, again, collision avoidance built into its tool paths to help recognize and avoid those fixtures and clamps, and global toolpath editing, so you can make changes to the settings of all your toolpaths at once instead of having to do it individually. So similar to FeatureCAM, there are two different packages available for Power Mill. There is Fusion 360 with Power Mill Standard or with Power Mill Ultimate. The key difference with these, of course, is the capabilities of Power Mill Standard versus Power Mill Ultimate. But there also are another difference within the package, which is the Fusion 360 with standard comes with the machining extension, but with the addition of PowerMill Ultimate, it also includes the additive build extension. And both, again, include HSM Works. So access to tools to program advanced CNC operations from 5-axis milling, additive manufacturing, and electrode milling allows you to create high precision parts. So the highlights to this product really are its advanced 5-axis milling capabilities, as well as its ability to pair with Power Shape and Power Inspect to get even more capabilities. And here we have another video to highlight some of the tools for the 5-axis milling within PowerMill.
Today's parts are more complex than ever, often containing features and details that cannot be produced using 3-axis milling alone. As part complexity has increased, so have the demands placed on CAM software to generate safe and reliable milling programs. Autodesk PowerMill provides tools to make efficient 5-axis programming a reality. Its comprehensive suite of toolpaths has been designed to help ensure parts can be manufactured no matter how complex. Instead of offering a small selection of specialized strategies, PowerMill allows 5-axis motion to be applied to the vast majority of its toolpaths. Strategies such as raster finishing, projection finishing, corner picking, and flow line machining can all be set to run in 5-axis mode by simply selecting the appropriate tool axis setting. Once in 5-axis mode, users can choose from a variety of options to achieve the optimum tool axis motion. Fixed angle toolpaths can machine undercuts and other features by rotating your machine into a position for cutting with the rotary axis locked. For regions of your part that cannot be machined with a fixed orientation, PowerMill offers user-defined points, lines, or curves to control 5-axis motion, allowing features to be machined in one go. Lead and lean tool axis control can be combined with many toolpath types. The tool axis changes depend on the shape of the part being machined. Applying a small lead angle to a surface finishing toolpath combined with a tipped radius tool will achieve exceptional levels of surface finish on doubly curved parts. Automatic tool axis control is ideally suited for use with toolpaths such as swirl finishing, where the side of the tool is aligned with the feature being machined. This style of feature machining is used to cut pocket sidewalls and other ruled features with ease. For added control, PowerMill allows tool axis limits to be applied. These reflect the capabilities of the machine and are used to keep the toolpaths within safe working limits. Tool axis limits can also be used to restrict 5-axis motion in key areas of your part, effectively defining localized soft limits, resulting in even greater control of your 5-axis motion. Finally, all PowerMill 5-axis toolpaths benefit from intelligent tool axis smoothing, avoiding sudden and erratic machine motion that could result in dwell marks appearing on your mill part. Smoothing will also allow your 5-axis CNC machine to complete the milling cycle faster, saving yet more time.
Now we have our comparison between the standard and the ultimate versions. As you can see with the standard, you actually get all the way up through 3-axis milling, 3+2-axis milling, and 4-axis milling. The include benefits of the ultimate really come within the 5-axis milling space, and as well as additional power tools such as creating those electrodes, machine collision checking, dynamic machine control, simulation analysis, and the blade, blisk, and impeller milling. Next, we move into Power Shape. So Power Shape is a tool used to import, fix, and prepare complex models for CNC machining. So within Power Shape, you don't actually create any tool paths, but it does help prep your models for that final stage. It also has capabilities for nesting, so you can create your nested sheets for your cutting operations. But beyond that, it has tools for Electro Wizard for the EDM operations, so you can define regions and shapes and features within your models in order to design the electrodes that would be needed to create those. It then has rib capping, which allows you to remove that geometry from your model. So then when you mill the rest of the shape, it is not trying to apply tool paths to those areas that are going to be performed with the electrode. It also then allows you to split models into core and cavity halves to better design your dies for casting and molding operations. And lastly, it allows for reverse engineering. So you can take mesh entities and the probe clouds gathered from Power Insight in order to recreate models within Power Shape. So some of the highlights are really the advanced techniques within Power Shape for prepping your models for CAM using the nesting, Electrode Wizard, and other analysis tools. So Power Shape is available with the Fusion 360 with Power Shape bundle, which includes Fusion 360, Power Shape, and HSM Works. Lastly, by pairing Power Shape with Power Mill to create and mill nested components and design and machine electrodes for EDM, or create detailed dies for mold and casting, you're able to make the most out of both products. And so our last video for the day, we're going to be looking a little closer at the electrode design and milling process using Power Shape and Power Mill.
Many plastic molded parts have features such as grills, ribs, flips, and bosses that are used for ventilation, to assemble the finished parts, to hold internal components such as electronics, or simply to add strength. These features can be so small and thin that they are virtually impossible to machine, as the cutters would be too fragile. Instead, these types of features are made by electrical discharge machine, or EDM, for which copper or graphite electrodes must be designed and made. Power Shape uses a simple wizard to guide you through the process of creating ready-to-use electrodes. The first step is to select the region where the electrode will be required. Powerful flood fill selection makes this part of the process very simple by finding connected concave regions in a single click, even if they are composed of hundreds of faces. At each stage of the wizard, simply set the values you need and press next. Power Shape gives you complete control over the design of the electrode, including the size and shape of the extension surfaces and the predefined blanks of material. In many cases, an electrode, complete with all its associated 2D drawings and setup sheets, can be created simply by pressing next. The 2D drawings created by Power Shape are fully customizable, allowing you to define templates according to your own company standards. EDM is usually used after the majority of the machining has already been finished. Any mistake at this stage could be disastrous. Power Shape automates the setup of the EDM itself, removing the possibility of human error. Finished electrode geometry, setup sheets, and EDM scripts are all stored in a single .trode file, simplifying data management for all the downstream processes, including machining with power.
Next, we're looking at Power Inspect. So this is the last in the 3 Power Mill, Power Shape, and Power Inspect options. Power Inspect is based all around probing in order to analyze your materials either during or after your milling operations. So it has automated inspection tools in order to quickly design inspection programs, as well as manual inspection tools, which allow you to even use handheld inspection probes in order to inspect the devices. It has point cloud programming in order to quickly designate a point cloud in order to inspect. Mirror Wizard, so for any kind of mirror geometry or inspection paths, you don't need to reprogram the same thing multiple times. You can use the Mirror Wizard to replicate that inspection on other aspects. You can also do inspection without CAD, which allows you to inspect models even if they don't have a CAD, or inspect parts even without a CAD model. This can then be imported back into Power Shape to reverse engineer that model. And lastly, there's automatic collision detection for your probing device. Highlight is really the high precision inspection tools for the CNC electrodes and even for the manual and handheld inspection devices. So Power Inspect is available in Fusion 360 with Power Inspect, which of course comes with Fusion 360, Power Inspect, and then also HSM Works. And then the last application we're going to be looking at today is CAMplete. So CAMplete is a post-process and simulation tool. So after you've completed all of your CAM programming, you can use CAMplete to optimize your post-processing, simulate the tooling, and analyze the performance of your milling operations. It will detect collisions and over travels. It allows you to analyze that machine motion. And there are 2 different applications for CAMplete. There is TruePath, which is the standard CAMplete package, which allows for looking at multi-axis CNC milling machines. You can actually change the post-processing from one CNC machine to another within CAMplete. And you can even have other options to edit your post-processor within CAMplete. The other option is Turn Mill, which is specifically designed for Nakamura Otome multitasking machines. These machines allow for multiple CAM operations to be performed simultaneously by different tools. And so this gives you tools for machine synchronization to make sure that the machine is working as quickly as possible on the 2 different parts without any collision between the different cutting bits. And so highlights here are the ability to analyze and simulate the operations from any CAM software, and then being able to replace, compare, edit, and optimize your NC code output. Well, if you do have any questions or want to contact us for any other reason, you can always go to our website, m2t.com, or contact our sales through our phone number or by emailing salessupport@m2t.com. Thank you all for your time and for joining us for this webinar.